Taking apart my Ford New Holland 1520 tractor because it's almost unusable. It whines, the hydrostatic drive whines if you try to do almost anything other than drive around on flat ground in low gear. It's pretty much unusable. I can use it for snow plowing in the winter because it's colder and the hydraulic fluid thickens up a bit, and then I can plow the level driveway as long as there's not too much snow in low gear. But I'm finally taking it apart. I'm going to see if I can clean up and polish the rotating group in the hydrostatic drive. There's a pump and a motor that I'll have to clean and polish. I really don't know what I'm doing. Hopefully some people with knowledge in this area of expertise would comment on the video and let other people know not to do what I've done as far as using sandpaper or valve grinding compound to grind down the rotating surfaces. But you'll see what I've done in this video, and at the end I drive the tractor around and it actually worked. It's been almost a year now and I've been using the tractor periodically, and it's working awesome. Middle of summer, it's hot out. I can drive down the road in high gear. I can pull the rototiller in low gear, even medium gear. Although I don't want to push it. The polishing I did I wouldn't really call it polishing. I just kind of ground out the scores that were in the rotating group, and I'm hoping that it's okay what I've done. I'm hoping that the kind of sanded down surface is reasonable enough that it won't remake bypass areas where the hydraulic fluid will squeeze through some path where it's not supposed to go and end up squealing again and producing no power at the wheels. I probably should have spent a bit more time after the initial grinding and actually polished the surfaces, but I really don't know what I'm doing, and at some point I just decided to put it back together, that it was good enough, and I thought I'd try it. I had no idea if it was even going to fix the problem or make any difference to the drivability of the tractor. So I've got some pictures and some video, and hopefully this is helpful to somebody. So what happens in the hydraulic rotating group is that you end up getting these score marks across the rotating surface because dirt or maybe metal shavings are in the hydraulic fluid and they circulate through the system, and then over time they slowly create a path where they bypass, especially if you're, say, using your tractor in high gear and you're really pushing it, and instead of it, say, under load spinning the wheels, it ends up bypassing in the rotating group instead of moving past the high pressure relief valve, and then you slowly get this score mark. And over time, if you ever driving your tractor around and you hear it squeal, it's going to make this problem worse, and it's going to get worse over time. So if you're ever driving your tractor and you hear it squeal, you want to stop doing whatever you're doing pretty much as soon as you hear that sound. So here, as I mentioned, I have no idea what I'm doing. Right now I'm using valve grinding compound, which has a property to it where when you first start grinding, it's a coarser material, and then the more you grind, the finer it gets. It kind of breaks itself down, and so you would initially have a coarse grind on the surface, and then as you grind more and more and more on that same compound, it's going to become finer and finer. And in my case, I'm hoping that it becomes fine enough that I've got a smooth enough surface that it's going to be sufficient.
Nice back. Huh, what? Nice there. No way. Actually, not really. Huh, still quite in there. Look at that. Huh. Still this thing. Don't know what to do with that. A little bit noticeable, but I think maybe I might just have to wipe all this off and then be.
So here I started with this wet sandpaper, which is way too fine of a grit for what I need to accomplish on this surface initially. Found some 400 grit sandpaper, which I then moved on to. I really hope that this isn't too coarse for polishing, grinding, sanding this steel surface. Once I had that ground down a little bit, I then ground the two rotating surfaces together. So these two are normally two surfaces that run against each other, and I have seen this done before where you grind the two surfaces together. So I hope it's reasonable to do this, and I think it worked out okay. As you can see, while I'm grinding every one of these components, I'm doing a few rotations, and then I'm lifting off the part I'm holding and I'm rotating the part slightly so my hand is never putting the same pressure in the same place for too long of a period. Since I have no idea what I'm doing and I'm learning as I go and trying different things, you can see that probably the order I've done things isn't right, and you can maybe take the better parts of what I've done or even combine it with comments from people who say, hey, this is what you should do. Probably I should have taken it to a machinist with a lapping table and they should have done this for me, and then it probably would have been better than new. But I didn't do that. I wanted to fix it myself and see if I could do it, although hopefully I'm not creating more damage than improvements in the long run. But hydrostatic drive is made up of two parts. There's the input pump side, which has a swash plate, just as the motor side has a swash plate, and the pump will create the high pressure hydraulic fluid, which then will drive the motor. And so there's actually two rotating groups you need to take apart and look at and resurface or regrind. Depending on where the wear is. Mine's on both rotating groups, so I've had to polish both. There's a circlip here that needs to be removed that I didn't notice until now. it would probably be a good idea to keep all the pistons in the same holes as they were in originally. I don't know how big of a deal this is. Mine were all very nice. There was no wear on the piston surfaces, but it probably wouldn't be a bad idea to keep them in the same locations if you can. I had initially tried to mark them, but all of my markings wore off, so that was didn't work out for me. This rotating group is the pump side of the hydrostatic motor, and the side I took out originally is the motor side. I've kept them separate, so I'm marking which one is which. See that this surface is worn down between those slots quite a bit, and it needs to be polished in order for fluid not to flow through there when it shouldn't. So on this rotating group that I already polished, or ground, I don't think I should call it polished because I feel like I should have had more of a mirror finish on it. It probably could have used a lot more work. Maybe somebody that knows anything about hydraulics could comment and say, like, especially that plate probably is way too, what's the word, it's kind of like a dull finish. It's not a mirror finish at all, and I bet if it was more of a mirror finish it would probably work even better than it ended up working. like I'm getting closer. I still have a bunch of scratch marks in there. At this point, I think I'm just going to leave them. I don't know how much I need to do and if this is going to be okay or not. I feel like because those scratch marks aren't moving across the surface where the fluid can flow and bypass, it's maybe okay. We'll see. As you can probably see, I kind of want to be done with this, and I'm doing a quick initial pass with all the valves at the same time. I don't know if this is a good idea or a bad idea. I feel like it should work okay. Just a very short grind here with them all. Is this okay to put some valve grinding compound on the 400 grit sandpaper, which is probably worn down a lot? I have no idea. Seems to be working that well, so I moved to just a new piece of 400 grit sandpaper. Anybody that does this kind of thing at their job probably knows that the heavy scratches I've got in there are not an ideal surface for this. So I don't know. Making this video and looking back on it, this probably should have been like a polished mirror surface by the end. By the time I was done, I probably should have gone somewhere and looked at least what they do and been given some pointers, but this is where I'm at. So I'm pretty much done, I think, as much as I'm going to do. I've got the big scratches out that run across from the center to the outside. I still have lots of lines in there. I really hope those don't wear down the rotating group and act like kind of a coarse rotating surface against the rest of the components and wear them down prematurely. I probably should have used some finer and finer lapping compound. I really don't know if the glass I was working on is a good enough surface to end up with a really fine surface or really mirror-like finish. Comments would be great on how this looks compared to what a professional ends up with. Thanks. So I've got a bucket of hydraulic fluid and I'm just kind of covering all these surfaces in that fluid before I reassemble it back into the hydrostatic pump and motor. part I've just put together is the motor. So inside it, there's a fixed angle swash plate kind of on the left-hand end of the aluminum housing I just screwed in or bolted in. You can see on the housing it's kind of angled. So in that case, when the hydraulic fluid comes into that motor, it's going to move through that rotating group in such a way that it ends up spinning it, because the pistons are sticking out of the rotating group near the top half, and near the bottom half they're shorter, they're more inside. So as that rotating group spins, the pistons are constantly moving in and out. And I guess it makes sense just to watch a hydrostatic drive animation to understand it. But in this case, with this tractor, the whole hydrostatic drive is all in one unit. They're not always like that. But on the pump side, on the right-hand side there, where the input shaft goes into the bell housing with the clutch assembly, it has a swash plate that you can adjust with your foot. And so as you adjust that swash plate one way or the other, that pump is going to spin or pump the hydraulic fluid either one way or the other, and that'll make your motor spin forward or backwards.
Alright, so I've got it back together. Got all these connections back in between the front and the rear. Got hydraulic fluid back in it. Got everything back on this side. So we'll start it up here and see what happens. Started. Sounds okay as far as the hydraulic noises go. Hear anything funny? Go back in four-wheel drive. Alright, see what happens. So, it's in medium right now. So normally in medium, I could kind of drive if it was on level ground. High, if I put it in high gear, it would, oh, that's interesting. Doesn't sound great. If I put it in high gear, I could never go anywhere. It would just whine. I had to do all my driving in low. So I'm gonna start out medium here. All right. It moves. No way. Actually moves. Okay, so far it's so good. It's actually driving. We got here a hill. It's relatively steepish. Usually I couldn't drive up here in medium, so let's see what happens. No whine so far. Yeah, so it's pretty steep, so the engine's bogging down, whereas before, when it got steep, they would just start whining. So should we try high gear? It never worked. Right here in high gear, I would not be able to go anywhere. Oh my gosh. Look at that. It's working. It's actually working. No way. Oh my gosh. Reverse. Reverse is working. Wow, this is amazing. Huh, this is so cool. High gear. I can like actually drive around. Wow. Huh. Well, that's awesome. excited. We try low. So I could only ever used to be able to drive it low, which is very slow. But now I assume it's gonna have more torque. I think I can go up this hill right here. Well, this is low, so I should be able to make it up there. Oh my gosh, no problemo. Woohoo! Ah, this is so cool. Back to medium. Oh, I'm so excited. Yes. Well, I'll have to put the rest of the panels back on here. But that is so awesome. It worked. It actually worked. I can't believe it. Wow. All right.